Hello, this is Shannon Seaver. Today we are looking at linear inequalities in two variables. On the agenda is to graph a linear inequality and to use mathematical models involving linear inequalities. So a linear inequality in two variables. If we change the symbol, the equal sign, in an equation to a less than sign or a less than equal sign, so this is less than equal, greater than or greater than equal sign, we obtain a linear equality. A solution to the linear equality is a ordered pair, xy, such that when those values are substituted into the inequality, they make the inequality true. So the outcome is true. So let's look at a solution and see. So determine if 2, 3 is a solution of an inequality. So just like when we had equations to test if a solution was, a point was a solution, we just substituted in. So this is our x value, this is our y value. So on this one, it'll be 2 plus 3 times 3 less than 19. So if I multiply this out, I'll have 2 plus 9, and that ends up being 11. Less than 19. 11 is less than 19, so this is a solution. Okay? Let's test the other one. -4 and 3. So I'm going to put -4 in for x. I'm going to put 3 in for y. So we have -4 is greater than or equal to 5 times 3 minus 13. Well, -4 is greater than or equal to 15 minus 13, and then -4 is greater than 2. Well, -4 is not greater than 2, so this is not a solution. So let's look at what we have to do to graph linear inequalities. First of all, we're going to take the less than or greater than symbol off the inequality. We're just going to make that an equal sign. And we're going to draw the line on the graph. Now, one of the things you need to know is it a solid line or a dashed line? We're going to draw a dashed line if it is like this. Okay? That means less than or greater than. And notice that because it doesn't have the equal sign under it like this, it doesn't include the line. So we're putting a dashed line there to signify that that's where it begins, the solution begins, but it does not include the line itself. Number 2, we're going to test a point on one side or the other of the line. We want to do that so we can see which side of the line to shade. So we'll substitute that point into the line to see if it's true or false. If it's true, we're going to shade the side of the line that the point was. If it's not true, we'll shade the other side. So, the other thing you can know is if it's already solved in y equals mx plus b format, we will shade the top half. If it's in less than mx plus b, we will shade underneath the line. So let's look at an example. Here we have 4x minus 5y is greater than 20. Notice that because it is greater than, we're going to use a dashed line. Okay? And since it's not solved for y, it's in standard form, I'm going to use the intercept rule to find my points. So if I put 0 in for y, I get 4x is equal to 20. X must be 5 then. So my first point I'm going to plot is 5, 0. Now if I put in 0 for x, I get -5y is equal to 20. Y, therefore, must be -4. So my other point is -0, -4. So here I have my point there, and I have a point here. So remember, when I connect my dots, I'm using a dashed line because it is a greater than sign. So here, I'm using my dashed line. Okay, so now we need to determine what side of the line to shade. So the easiest point to pick, in my opinion, always is to pick 0, 0. So if that's an option that you can use, then use it. So I'm going to put 0, 0 into my equation. I have 4 times 0 minus 5 times 0 is greater than 20. Well, 0 minus 0 is 0, and that is not greater than 20. So I am not going to shade the side where 0, 0 is. I'm going to shade the other side of the line. So on this one, I want you to pause the video, take a moment, and graph this one to see if you get something close to what I get. Okay, so on this one, it's in slope-intercept form, and you can really think of the intercept as 0, so I use that as my first point, and then I use the rise over run to find my second point. I use the point 0, 1 to test, and if you notice that 1 is not less than 0, so this side is not going to be shaded, but this side will be. So now I want you to look at this one. We have y greater than -2. And in this case, remember, we have vertical and horizontal lines, and the fact that it says y, this is going to be a horizontal line at -2. So if we go across like this, and once again, it's a dashed line because it doesn't have the equal sign underneath it, and it says y is greater than that, so I'm going to choose this side to shade. That is the end of this video. If you have any questions, bring it to class tomorrow.